So now in this video we have a 555 timer, and thanks to a photodiode right now, the output is low because it's bright enough. When it gets dark enough, then the output is high and the red LED lights up like that. So now zooming in, we have the circuit here. The first thing is we have pin number 2, that's the trigger pin. We are holding it low. When pin number 2 has a low input, less than 1/3 of the supply voltage, it wants to hold the output high. So you don't quite get 5 volts, but relatively close, maybe 4. And the red LED lights up like that. The reset pin though, pin number 4, is more powerful. And when it has a low input, which I believe is about 0.5 volts or less, it's pretty low, then it will set the output low no matter what anything else wants to do. So it overpowers the trigger pin right there and connects to ground really well, actually, through pin number 1. Pin number 6 is the threshold pin. I have that connected to the negative supply just to make sure it doesn't do anything. It's waiting for 2/3 or higher supply voltage. And that's the basics of the circuit. We'll look at the physical circuit right after this. But in any case, we need a pull-up resistor to hold the voltage at the reset pin high enough that it doesn't activate until we want it to. And so 100K seems to work pretty good with the photodiode here. So we're using a photodiode, not a light-dependent resistor. I believe for about the same circuit you want about 10K resistor for a light-dependent resistor. Light-dependent resistors are a lot more common, but I've been doing a lot of videos lately with the photodiode and some with the 555 timer. So it was a good time to combine them, plus somebody asked if you could use a photodiode for this basic circuit. So we'll come over. So I was thinking of doing this video anyways, but since somebody asked, that really sealed the deal. So we got to power it, positive supply, pin number 8, negative supply to pin 1. Trigger pin, pin number 2, held low there, less than 1/3 supply voltage. Again, it wants to keep the output high, but it can only do so if it is dark enough because the reset pin, as we just saw, overpowers it. So enough light falling on it, it connects to ground pretty well. You got to remember that to use it reverse bias, when I was testing this, I accidentally put it in the wrong way and it did not work. So reverse bias there, and we'll put it back. So the short lead, the cathode, more positive there. The longer lead, the anode there. But you can see it's going to ground, and that's a 100,000 ohm resistor right there. Again, light dependent resistor, if you're using there, I find a 10K gets somewhat close to the same results. And then we got the output. The output's low because enough light is falling on there. Positive, headed to negative. These, the long lead, the anode, more positive, short lead, the cathode, more negative for both LEDs. And then when it gets dark enough, now the trigger pin is able to set the output high. And again, high, positive coming through the LED and the resistor. I have a higher value resistor for the blue LED because it's brighter than the red LED at the same amount of current. So to kind of equalize the brightness a bit, I have much more current going through the red LED.